Hello and welcome everyone to the fourth session of this year's Architecture and Philosophy series. So after three wonderful sessions, we have a very special guest joining us today. Tom Froese is a cognitive scientist and associate professor at the Okinawa Institute of Science and Technology, where he is the head of the Embodied Cognitive Science unit. Tom did his PhD originally at Sussex with Ezekiel de Paulo, who, as you know, is a very prominent figure in enactivism, of course. So Tom is a renowned researcher working across the fields of embodied cognition, robotics, artificial life, complex systems. You can already tell it's very, very interesting research. And one central question I just took from his profile that I wanted to highlight is, how are agents transformed by the interactions in which they participate with others? I think that's a very profound and very, very interesting question that I think many of us also share. And then I'm sure some of you will be familiar with Tom's work on eruption theory, and I'm sure we'll be touching upon consciousness in the discussions also. Well, the name and topic of this session is Francisco Varela, New Perspectives. Varela, in a way, needs no introduction. He was, of course, a Chilean biologist who transformed our understanding of cognition, life, and consciousness. He's oftentimes associated with Humberto Maturana for their work on autopoiesis and self-organization, but he just as much laid the groundwork for the enactive approach to cognition, along with Evan Thompson and Eleanor Roche in their book, The Embodied Mind from 1991. Varela also had a great interest, of course, in Mahayana Buddhism. And to the best of my knowledge, today is the first time we're discussing Varela on digital futures, but also not just Varela, but also by extension, second-order cybernetics. And in a way, today's session also connects beautifully to the upcoming session of Dulmini Pereira on April 6th on Gregory Bateson. So without further ado, Tom, thanks so much for joining us today. I'll hand it over to you. We look forward to the presentation and the discussion.
Thank you so much, Michael, for the kind introduction and for the kind invitation. I very much look forward to discussing with you and everyone afterwards. It's a new community for me, so I'm very curious what brought your interest to Francisco Varela's work and these topics. So I very much look forward to finding out more. My plan is to just lay out a little bit of Francisco Varela's work, especially like in the later part of his career, and use that to set up then some of my own thinking on these topics, and then we'll have a nice discussion in the end. All right, so let me just quickly say a few words about where I'm coming from so you understand my perspective. So as Michael mentioned, I'm the head of the Embodied Cognitive Science unit here at OIST. And in a way, the way I think of our scientific mission is to put embodied cognition to an experimental test. So for most of my career, my main focus has been theoretical, conceptual work, philosophical work, modeling work, and I do feel that the enactive approach has given us one of the most sophisticated, most articulated, conceptually most rich frameworks for thinking about the mind, and indeed how agent-environment interactions shape and constitute our cognitive capacities. But it has been a bit difficult for the field to make impact in a more concrete way in terms of experimental successes, for example. So here at OIST, our mission is to combine these conceptual advances, theoretical advances, with the kind of scientific support that OIST provides. And so in our lab, we do brain imaging using EEG. We look at all the other physiological systems in the body that can be related to cognitive activity. And so we don't just look at the brain, we look at the brain as part of the larger organism. And in the case of the human, of course, our environment is crucial. As architects, I'm sure will know as well. And let's talk about that later. I'm very curious to hear your perspective. But in a sense, what makes the human mind unique and different from animal minds is that we're integrated into an environment that is of our own making, that's technological, cultural, social, and it's these kind of complex loops which enable a lot of what makes human cognition special. So, sometimes when I talk to students, the way I present this unit is that unfortunately, we have to know all the sciences in order to make headway to understand the human mind. We have to know about thermodynamics. We have to know about the energetics of the brain. We have to know, how does it all fit together, the chemistry, the biology. We have to zoom out and into the environment, the ecology of the environment. We have to zoom out further into the social systems and technological evolution. And so at least for this planet, to some extent, we go from the smallest scales of analysis to the largest scales of analysis. And no matter which scale we pick, something can be related to human beings. We even affect the climate on a global scale, right? So that's really one of the challenges, I think, that, to some extent, cognitive science is the science of all sciences, and even reflexively so. So we mentioned second order cybernetics. In order to understand what is observation, scientific observation, we have to know something about what is perception, and how do we relate with the environment. And depending on how those concepts of relation pan out, they might change everything in terms of how we think of all the rest of the sciences. So there's a lot of things at stake in thinking about, what is our best science of the mind. So having said that, what's Varela's take on this? And how does it stand out from other kinds of views of the mind? So he was very prolific in his work, and you can distinguish several different stages. And I will not talk about his entire career because it would be taking us much too much time to do that here. So in his early work on the neuroscience of vision, for example, so he was trained as a neurobiologist, working on vision in pigeons, for example, with Maturana. You can read his work very much in the line of second order cybernetics and radical constructivism, where the contact with the world was always a little bit, I don't know how to put it, at issue. It's something more of the sense where the autonomy of the organism or the autonomy of the agent was guaranteed by an indirection whereby the environment could not specify any particular behavior, but could just provide a perturbation to which the organism would then respond. And this is sometimes called structural coupling. And our complementary notion that fits with this is autopoiesis, which is that the system itself, through its metabolic cycles, creates itself, creates its own components, defines its own boundaries, and there it defines the domains of structural coupling with which it can engage. And so this is a notion of biological autonomy that was very dear to his heart in the beginning of his work, but which very much was influenced by Maturana's work. So at that time, a lot of the work that comes out is indeed Maturana being the lead author. And so we're not going to talk about that part of his work. We can go back to this during the discussion session. But we will basically enter his work where Varela himself starts to have some doubts about whether this is exactly the correct way of conceptualizing things, or maybe some things need to be changed. And this is the second part here that we will enter into in more detail, which is the mind-brain identity theory that he works on with Evan Thompson, which then gets expanded into a kind of live body identity theory in work with Andreas Weber, where also the notion of autopoiesis eventually makes a comeback. And then the final work towards the end of his life, especially with Nathalie Depras, Varela starts to bring in more and more of the Husserlian phenomenological tradition into his thinking, and his thinking about the mind-body relation becomes a lot more complex than what we find in the initial works. And then the question is, where should we go next? Varela's work was not completed. It feels a little bit like that the last part of his work was just the preparation for some bigger revolutionist thinking that unfortunately remained unfulfilled. But I think we can draw on a few pieces here and there in his corpus to get a sense for where he might have gone next. And we will explore that at the end of this talk. So the way I will do this is that I will stay quite close to Varela's work itself. So please forgive me if there's a few longer quotes, but I think it's important to let him speak in his own voice, at least in the initial parts, and then later when I talk more about my own work, I will reduce some of the use of the quotes. Okay, so as I said, there was a transition in Varela's work that happened at the end of the 80s, beginning of the 90s, where he basically stops collaborating with Maturana and starts envisioning a research program that takes in a different direction. And so here's a rare moment when he's reflecting on this transition. Let me just read it. So he says, one of the criticisms that can be leveled at these ideas, as well as to the ideas expressed in my book, Varela 1979, which, by the way, will be re-released by MIT Press soon. It's a great book, so please take a look at it. Is that our critique of representation as a guide for the cognitive phenomenon is replaced by a weaker alternative. The external as a mere perturbation of the activity generated by the operational closure of the organism. And operational closure here can be read as a kind of generalization of the concept of autopoiesis beyond the chemical domain. And we can see that Maturana's efforts here, in a way, are critical response to the representational paradigm, which was the dominant one at the time in cognitive science. Which in turn was a response to the kind of behaviorism which dominated psychology before that. So it's not a return to behaviorism, but it is a rejection of the representational paradigm in favor of a notion that is more indirect, such as structural coupling. But as in any paradigm shift in science, when all you have in a way is a negative critique, it's hard to shift the mainstream unless you have a stronger alternative. And here he explicitly says that the critique was only giving us a weaker alternative. And the reason why is that structural coupling does not properly take the account of the emergent regularities in the course of a history of interactions during which recurrent interactions the cognitive range is constituted, neither on the one hand internally in a way that leads us to solipsism, nor on the other hand externally as desired by the representative traditional thought. So here we already have a concern that surfaces throughout this work, which is that there's a temptation to fall into extremes and polarizing in one way or the other. And we should beware from being tempted to do that. So neither pure internalism or solipsism or individualism will work because we lose contact with the world. But neither can we assume that the way in which the world shows up for us is a true veridical representation of an independently existing reality. Okay, but then what's the picture that we actually have? If neither of these is classical alternatives is, adequate, what else do we have? So he proposes a middle way. Okay, so this is a kind of, I say, Varela rebooted. So this is a revitalization of his own research program. He says, over these years, I've developed an explicit alternative that avoids these two possible traps, turning the historical reciprocity into the clue of a co-definition between an autonomous system and its environment. I propose to call this point of view in both biology and cognitive science enaction. Okay, so here we then have the kind of mission statement of the enactive approach to cognitive science as a way of presenting a stronger alternative to the representationalist paradigm in a way that avoids some of the weaknesses that Varela identified with the previous autopoietic tradition, or the second order cybernetics tradition. This approach most famously was elaborated in these two monographs, The Embodied Mind, which we heard also in the introduction, which came out as a second edition recently. After Varela's death, Evan Thompson brought out Mind and Life, which was based on manuscripts the two had worked on together, which was supposed to be a follow-up to the Embodied Mind, but which then Evan Thompson completed by himself, which basically provides a more biological grounding to the first book, which mainly focused on phenomenology, Buddhist psychology, and perception action loops. So Mind and Life basically generalizes and broadens this perspective. One thing that Varela was very interested in as part of the enactive approach was to bring in something that he had interested in since his early years, which was phenomenology. And so in Paris with his neuroscience group, he was very actively involved in discussions around the relationship between Husserlian phenomenology and cognitive science. And to some extent, the enactive approach was a way of proposing a cognitive science that was informed by phenomenology, and which in a way was supposed to give back to phenomenology a kind of scientific feedback. And here we see this a famous edited volume that brought together a lot of authors thinking about this relationship. And in this blurb, they say what clearly emerges is that Husserlian phenomenology cannot become instrumental in developing cognitive science without undergoing a substantial transformation. And this, what they are referring to here is the issue or the question of naturalization. From the point of view of a kind of transcendental phenomenology, maybe it's the concept of nature that to some extent gets subsumed by some notion of subjectivity or consciousness, whereas from the point of view of cognitive science, it's precisely the transcendental subject that is problematic. So the question is, how can these two traditions meet each other? And at least during these days, it was more on the side of phenomenology that the work was supposed to take place. That, in a sense, phenomenology was giving methods for refined first-person descriptions of the structures of experience, which then could be investigated in terms of their neural correlates, for example. But in a sense, it's the sciences themselves were not changing, at least at this, it's not seen as changing so much, at least in this early encounter. We can see this in one of Varela's very famous papers where he responds to the challenge of the hard problem of consciousness that Chalmers posed. And the basic idea is that we can imagine a scenario where we knew everything that physics could ever tell us about the universe, but possibly consciousness could still remain a mystery. So just because we know everything about the physics of the universe doesn't necessarily entail any knowledge of conscious experience. And so that makes it very difficult then to think about the relationship between nature and consciousness. And the kind of popular way of putting this is a philosophical zombie. Right now, if you look at the best neuroscience we have of how the brain and the body generate behavior and interaction with the environment, let's say at the neural level, there's nothing there that would suggest that this is an incomplete account in a way. And so we could imagine that I could be given this presentation as long as all my neurons are firing the right way without having any conscious experience or any sense of agency at all. Okay, that's the idea of a philosophical zombie. And that, of course, seems outrageous from our own first-person point of view or from our communal second-person point of view. But then the challenge is to pinpoint why is it outrageous and how would our first-person experience actually make a difference to how our behavior is generated without at the same time then violating any kind of the fundamental principles of the rest of the sciences. And so in this paper, Varela's proposal is a methodological remedy. So as he says here in this abstract, first-hand experience is indeed an irreducible field of phenomena, and he claims there's no theoretical fix or extra ingredient in nature that can possibly bridge this gap. And that's a pretty skeptical conclusion, straight off the bat, saying, well, there's nothing that we could ever do as scientists to explain how consciousness, emerges or is related from natural phenomena. But he has a proposal, which is that instead of giving up working on consciousness, the science of consciousness completely, what we can do is work on both sides of the gap, so that phenomenological accounts of the structure of experience and their counterparts in cognitive science relate to each other through reciprocal constraints, which basically means that if we know something about how the brain works, that puts limits on what we can say about the experience, such that, for example, if someone's is brain dead, then there could not be any kind of rich experience happening at the same time. On the other hand, if we can elicit reports of a subject undergoing varied experiences, then we might expect that their brain activity also exhibits some kind of a corresponding diversity. These kinds of relationships. That's what he means by reciprocal constraints over here. But in the same paper, he reflects about what kind of theory is this really, this reciprocal constraint theory. He says, still, is this not just a fleshed up version of the well-known identity theory, or at least a homomorphism between experience and cognitive neuroscience accounts? And the issue here with the identity theory, which is usually a mind-brain identity theory, is that in a way, it doesn't enable experience of the mind to make any difference in its own right. It's just the way nature is that to some extent, all the causal efficacy is offloaded, so to speak, to the neural part. And it just so happens that those particular neural parts also are your experiences, but we could still tell the complete causal story on the side of the neural part of how you get from a particular environmental state to some processing in your brain, to then particular behavior being generated. So he doesn't say it explicitly here, but from my point of view, I mean, the issue here is that that's not so different from saying that experience is nothing but an epiphenomenon. It doesn't really do any extra work here. No, there's no explanatory work being done by just saying that a particular neural pattern is also what your experience is. So he wants to reject this. He says, so not really. It's not this identity theory, since I'm claiming that the correlates are to be established not just as a matter of philosophical commitment or physicalist assumption, but from a methodological sound examination of experiential invariance. It would be missing. Okay, wait, actually, this is important. So the key innovation that he proposes here in terms of methodology is the elucidation of more detailed descriptions of real experience, concrete experience. Okay, first-person accounts, maybe elicited through second-person interviews, is what the phenomena are that we should try to explain. And that indeed is an innovative move. But in a sense, it doesn't change the kind of conceptual structure of how those more detailed reports relate to the neural. And indeed, then he says, it would be missing the point to expect from the neurophenomenological approach some completely new insights into empirical mechanisms. And for someone who's read this paper many times, when I was a student and also later, I somehow must have skipped over this part, because for me, at least, neurophenomenology always had the promise of telling us something new about how the brain works. And that's what made it so attractive. So just going through this more recently again and finding this quote that we should not expect completely new insights is interesting, but it's consistent with the rest of the paper that what's really the novelty here is to bring in these phenomenological methods to the brain science, but the brain science itself is not really being changed from this point of view. On the other hand, we do find parts and other works where it's clear that the ambition is to do more than to have an identity theory with a bit more of a phonologically detailed account on the side of consciousness. So here's one of his papers with Evan Thompson, where they discuss neurophenomenology, and they say it strives to crisscross the explanatory gap, which is another word for the hard problem of consciousness, by using the conceptual tools of one, large-scale perspectives on the synchronization of brain processes and transient global patterns. Two, dynamical systems theory for understanding emergence as reciprocal causation in the context of self-organization. And three, enactive cognitive science for understanding the embodied and embedded nature of the brain dynamics underlying the unity of consciousness. A distinctive feature of this neurophysiological approach is that it allows conscious activity to be a causally efficacious participant in the cycles of operation constitutive of the subject's life. And indeed, this final statement that this approach allows conscious activity to be causally efficacious, right, is what got me excited about this approach in the first place. And I think many people in the enactive community buy into this and believe that the biggest selling point of enactivism is, in a sense, to allow first-person experience to make a difference in its own right to how we generate our behavior. And it's intuitive, right? To some extent, that's where we always start from. And that's also how the embodied mind started in the beginning, that before we become scientists or philosophers, we are always already in the world, acting for reasons, having intentions, and so on. And it's only when we adopt our, academic hat, so to speak, and then start entertaining skeptical doubts and becoming committed to conceptual structures and so on, that things become less clear. But before that, we're always already acting causally with respect to our experiences. So a scientific framework which promises to be able to explain how it can be so is very attractive. But let's just have a closer look at these three principles, okay? Number one, large-scale synchronization in the brain. Okay, transient global patterns. Indeed, this is, maybe in the 90s, this was less well studied. Freeman was one of the exceptions, along with Varela. But I think more recently, presumably there wouldn't be many neuroscientists who would deny that large-scale synchrony in the brain plays an important role in organizing cognition, for example, or in organizing behavior. So, but there's nothing there in the dynamics of synchronization that says anything about consciousness or conscious activity per se. So yeah, it's true, it's important, and maybe it has been overlooked historically, but it doesn't require us to commit to anything more strong than that. Same goes for the dynamical systems theory. So yes, it's true. We can think of the brain as a complex adaptive systems with different scales, multiple scales making a difference in their own right, whether we're talking about neurotransmitters or neurons or different areas or large-scale functional networks and so on. And these, the activity bubbles up, and then once it's there, it sets conditions for the lower level activity and changes it. Yes, so again, that's true. But someone who would just want to adopt a complex systems perspective on the brain can do that without buying into the whole enactive package that would also say there must be something about conscious activity that is also causally efficacious. It doesn't show up by just adopting this point of view. And then in terms of the third principle, enactive cognitive science, more generally, well, yes, the brain is in a body, it's embodied, and the body is embedded in an environment, and there are complex interactions between these systems. But again, there would be multiple research programs that would agree with this. There's, enaction is not the only e-game in town. There's a whole 4E cognition of different ways of thinking about these interactions. And again, we could simulate these kinds of interactions on a computer using evolution robotics or agent-based simulation models where we can, in very fine detail, look at the dynamics of how brain, body, and environment interact. But again, there's nothing there that would say that conscious activity can be causally efficacious. Quite the opposite. As long as we adopt a deterministic dynamical systems framework, there's actually nothing other than the initial conditions and the equations of the system that we need to know about. Everything else follows in a pre-specified way. So there's a tension here, basically. This took a little bit longer to unpack, but I think it's important to give it some context that there's an ambition, and it's clearly stated, and there are some conceptual tools which are offered to do the work. But it's clear that there's still some additional work to be done in order to properly ground the claim for consciousness to make a participatory difference in these cycles of operation. So there are strands in Varela's work where we can get a glimpse of a different, maybe more nuanced view of the relationship between mind and body. It's almost like in parallel, there's another Varela going from the 70s to the later stages of enactivism, which is to some extent a different view of this relationship compared to the more traditional Maturanian or also this identity theory one. Here's one example from the 80s where he says that the world should have this plastic texture where it's neither subjective nor objective, not one inseparable, neither two and inseparable, is fascinating. It points both to the nature of the process, which we can chart in all of its formality and materiality, as well as to the fundamental limits about what we can understand about ourselves and the world. And so this not one, not two complex relationship comes from even the 70s where Varela cites Suzuki's book, Zen Mind, Beginner's Mind, which basically treats the relationship between mind and body as this not one, not two way. What's interesting here is that he brings in the notion of limits, and we will come back to that. Perhaps one way of trying to conceptualize the relationship between the subjective and the objective is in terms of the limits that they impose on each other, that there's a kind of incompleteness in the relationship between the two. Here in the 90s, here's another way of defining enaction. So enaction in the embodied mind was defined essentially in terms of perception-action loops, that action is perceptually guided and perception is also based on action. And so this is kind of a loop between perception and action. Here we see a different definition of what he means by enaction. He says, the hinge that articulates enaction consists of fast non-cognitive dynamics, wherein a number of alternative microworlds are activated. These hinges are the sources of both common sense and creativity in cognition, the key ingredients for a tasty nouvelle cognitive science. It is the very presence of this unruliness that allows for the constitution of a cognitive moment according to the system's constitution and history. The very heart of this autonomy, the fast time of the age's behavior selection, is forever lost to the cognitive system itself. So a couple of things here. First of all, interestingly, enaction now becomes defined as something that is non-cognitive. It's unruly, okay? So it's messy. But it's a hinge in the sense that, some kind of transition is going to happen when it's present. But this autonomy, this openness to change, is not actually accessible to the cognitive system itself. So it's unconscious. So that's a very different point of view from starting from phenomenology, for example, right? So here we're really talking about things that are perhaps inaccessible to our first-person perspective in principle, and yet they're being posited as the very heart of our autonomy. So it's an interesting shift in perspective. Then moving now to the final stages of Varela's work, so we can wrap up this part of the presentation, his work with Desprages. we now find that he's returning to this more complex, more nuanced, almost paradoxical way of talking about the mind-body relationship. They say it is a two-way street. The local components give rise to the emergent mind, but vice versa, the emergent mind constrains and affects directly these local components. Epilepsy, something that Varela worked on a lot with his group in Paris, is of course a good example of local properties, the local currents, leading to a global state, the crisis, in a lawful manner. But we are also able to find evidence for the converse. If a patient engages in purposeful cognitive activities, such as recognizing a visual form, we could see changes in the detailed attributes of the local epileptic dynamics. And again, this is key here. Like, is this causal efficacy of the mind, right? So, and somewhere else, I think there's a claim that if a person could sense in advance that they were going to have an epileptic seizure and they engage in a certain kind of cognitive gesture, then perhaps they could reduce the likelihood of suffering from a seizure. So, there's something at stake here. It's not just an empty discussion. But to exactly understand how it is possible that, becoming aware of an imminent seizure and then acting accordingly, how should we include this awareness in our description of what happens at the neural level is difficult unless we talk about some kind of reciprocity between neural dynamics and this kind of conscious cognitive dynamics. So according to them, this dualism of mind and matter as forever apart, now merges into a new conceptual space. Our minds are enmeshed in multi-level causalities in the material basis of our bodies, just as much as this organic basis is the substrate from which our mind can be said to emerge. A purely one-sided emergence view that deprives experience of its active dimensions is bound to negate its understanding as a mere epiphenomenon. Okay, so this final point is easily said, but it's hard done. In the sense that if I go to a neuroscience lab and I knock on their door and say, well, if you don't have an account of how consciousness can make a difference, then your theories are self-refuting and therefore should be discarded. It's not going to make it, nobody's going to listen to that kind of argument. What they want to know is, do you have a better theory that will somehow improve my, scientific practice in the lab and will allow me to make breakthroughs that otherwise I wouldn't have been able to do? And so this is the challenge, really, that if we are to argue for such a new conceptual space, where we argue for mind being somehow enmeshed in the material basis of our bodies, as it says here, then this should show up somehow in our measurements. It should make a difference, a notable difference in how the brain works. And it's not enough to just, argue negatively that if we don't assume this, we're basically going to have a self-refuting theory on our hands because of turning experience into an epiphenomenon. Okay, let me just maybe skip a little bit here and move on. So then this is the schema, in a way, that emerges from these considerations. We have an intention to act according to our experience. That then leads to some kind of unruly, non-cognitive, fast-paced dynamics out of which self-organizes an action. With Varela, we can say here, within the gap during a breakdown, there's a rich dynamics involving the concurrent sub-identities and agents. He's thinking here about Society of Mind by Minsky. This rapid dialogue is invisible to introspection, so something escapes our awareness. So even though from our first point of view, if I intend to move my hand, I have the experience of doing it, I have a sense of agency, I don't actually have awareness of how my intention gets transformed into this kind of bodily activity. But this breakdown is curious, and I think it's key to understand this breakdown in a more formal way. And so I propose a specific concept to unpack this, which I call eruption, which comes from Latin to rush into, invade, break, burst. So this is the kind of etymology. So I'm going to take Varela's work that basically pointed to this indeterminism as somehow being an essential element for our autonomy and for realizing our actions as free agents, and unpack this a little bit more systematically. Okay, so I'm going to switch now. Now we'll talk more about more recent work, and hopefully you will see that in a way this is a continuation from some of the strands of Varela's thinking. So the mind-body problem, theoretical limits. I'll go a little bit faster now. We can distinguish two parts. Consciousness, there's a part of agency, which sometimes you can talk about in terms of mental causation, and there's a part of subjectivity, which is the other way around. Experience is emerging, and it's good to keep these separated. A lot of the times people don't, but in this nice book by Peter Godfrey-Smith, he tells a nice evolutionary story that we can actually conceptually and empirically separate these aspects out. Then we have an issue, which is that when we come to studying the neuroscience of consciousness or agency or subjectivity, we don't find anything. Okay, so this is Thomas Fuchs in his book In Defense of the Human Being. So although he's a humanist and he wants to defend all of these concepts, he's forced to admit that, you know, no matter how closely we observe or measure, nowhere does something like subjective experience emerge, and neither can we find the level of human deliberations. Their effectiveness remains physically unobservable. Okay, that's shocking, right? So this is really where the big clash between the natural sciences and the humanities plays out. All the things that, you know, all the humanities that we say we do things for reasons, goals, projects, desires, intentions, you know, well, then when we come to our best natural sciences, we just don't find any of that. We can't measure it. What's going on, right? It's just, you know, stuff happens, but that's it. And there might be even reasons for thinking that there are limits to trying to overcome this problem. So here's Dan Hutto, another enactivist, saying that can consciousness be made intelligible in terms of something else? I mean, like brain activity, for example. He says, I argue that I cannot, not even in principle. And we can kind of see why, because imagine you would have to write out what it is to feel a particular sensation, you know, of listening to this talk right now, in terms of, you know, the different voltages that are happening to course through your brain at that time. It's just that the two things just don't translate into each other. It's the zombie problem again. So it's unintelligible. Even if we want to say it makes a difference, we don't know how it makes a difference. Maybe we could not even know how in principle. But at the same time, like I said, we do want to hold on to the claim that consciousness is physically efficacious in the sense that it, you know, it affects how we behave. And here in Alvin Noy's most recent book, he says the following: we are for ourselves like artworks, beings whose nature refuses to be known, but whose being unfolds in the activity of working to know and see. And so there's these two aspects, right? So on the one hand, we always escape our measurement, we always escape our definitions, and to some extent, he argues that's part of what it means to be human. But at the same time, you know, this is work, right? I mean, this is an effort. It's something that we do. Okay, it's an activity, and so at the same time, in a sense, we do make a difference for how nature unfolds. And so this then leads us to this intertwining of the two classical problems of the mind-body problem. We have the problem of mental causation. How do we make a difference with our bodies? We have the hard problem of consciousness. How does nature make a difference to experience? These two are interdependent. We can generalize it to mental content too. We can skip that for now. And so then eruption theory puts these things together and says, well, what we can say is that if man can make a difference to the world, but it's unintelligible in principle, what that means is that there's basically an uncertainty element in the measurements that we get. The more my mind makes a difference to my behavior, basically there will be an increase in the unpredictability of a certain aspect of the behavior generation process. It's the unruliness, as Varela would say. The unruliness increases with respect to how much effort I put into my behavior generation. and the other way around too. So if my brain at some point converts activity to making a difference in my experience, then it's a little bit like I have a cause, but the downstream effects are not observable. In that sense, there's a decrease and the difference is being made, and that I call absorption. The first one was the eruption one, the kind of like the breaking of the physiological tendencies and adding variability and disruptions. And the other one is an unexpected decrease in variability. So putting this all together, we have this view where we basically accept that the relationship between mind and body is something that we can't, in principle, directly measure scientifically or even experience directly. It's a little bit like a black box, but as long as we accept this, we can work with the uncertainties that are resulting from this. Okay, so then here's the general framework. We have concepts of individuation. How do we get individuals in the first place? Here we can draw on some of the early work that Varela did with Maturana in terms of autopoiesis and so on. Then the new part is this concept of eruption, where our involvement basically undermines the physiological tendencies. There's a kind of scaling component here. If disruptions are the way in which our mind shows up, given that we're at the edge of chaos as living systems, it means that even small fluctuations can be scaled up to the level relevant for behavior generation. And then there's a kind of process of self-organization or self-optimization. So over history of interactions, things that worked in the past will be more likely to be repeated. There will be a possible process of sedimentation, of stabilization. Affordances in the environment will call out the right kinds of behavioral responses. But in a sense, we're not directly in control of our behavior. What we can do is open the degrees of freedom that our body has by injecting extra variability into the processes. But it's really this the historical tendencies and our skills and our embodied memory and so on, and in combination with the environmental affordances, out of which then the actual behavior emerges, which fortunately enough, most of the time will be the one that matches what we're intending to achieve. And I have a few more slides about some neuroscience evidence and so on, but I already talked quite a bit, so I think I'll leave it like that so that we have time for questions. Thank you.
Wonderful, Tom. That was fantastic. That's I've so many notes. Neil, would you like to jump in here?
I mean, Tom, thank you. That was terrific.
Yeah.
Maybe, and I don't know enough about Varela, although he has come up actually in discussions on digital future, especially with Sanford Quinter several times. So he's a figure that we're all kind of aware about. Maybe I can talk about it from my own particular perspective. I was taught within the kind of phenomenological tradition at Cambridge. We had lots of Heidegger, lots of Gadamer, and so on. And then I moved to teach at the University of Nottingham, which was much more post-structuralist, and I was part of the critical theory group there. And with my doctoral students there, what we basically began to realize was a certain incommensurability between the phenomenological tradition and the post-structuralist position as regard the subject-object approach to things. Within the phenomenological tradition, it was though we were all one with culture. It was unproblematic. We were collapsed into culture. And what post-structuralism was trying to do, and I'm thinking here also people like Geoffrey Bennington, who were at Sussex as well, talking about Derrida, was that everyone was trying to problematize the connection between the subject and the object, the self and the other. It was a problem. And it became clear that these two were completely incommensurable. You either took one position or the other. And famously, of course, there were these debates that went on between Gadamer and Derrida, for example. It was just simply they were just like ships that passing in the dark. They couldn't connect in some way. And I guess that I'm surprised that it was Heidegger that everybody was locking onto in this cognitive science tradition, because there is an alternative tradition of kind of process-based philosophy that comes out of Alfred North Whitehead, and I guess the people like Gibson, and to some extent Deleuze as well, which was much more process-based and which finds itself much more amenable to engaging with the world of cognitive science. Now, a more recent discourse that's been going on has been, we actually had a session with Graham Harman last week, but there was a debate between Graham Harman and Manuel de Landa. I don't know if you know de Landa's work, but and it was funny because I know de Landa very well, and they had this debate, and Graham Harman kept thinking that they were thinking completely the same way, and Manuel de Landa said, no, we think completely differently. So, from my perspective, when I listen to sort of people like Anil Seth, the kind of the way in which he looks at predictive perception and kind of problematizes our way we predict the world, it is much more aligned with with that other tradition. Which also, in some senses, kind of fits in with the Lacanian tradition of psychoanalysis. In other words, and I put this to Anil Seth, and he doesn't like psychoanalysis at all. But in some ways, when you start taking on board the work of someone like Slavoj Žižek, who believes that the role of fantasy is precisely the lens by which we engage with the world outside. In other words, it's not a question about fantasy versus reality, but fantasy becomes a lens and it is constitutive of how we see reality. So you've got a kind of problematization there that is in some ways not so different to the notion of a controlled hallucination that Anil Seth talks about. So my perplexity is, why did people seize on Heidegger of all people in terms of philosophy from the world of cognitive science? Because I think there was a much easier tradition to lock into, which was accepting precisely the problems you were tussling with as a fundamental part of it. But I don't know anything about your world, and I was just fascinated by the thing. Let me confess one thing: is as a result of all one thing I heard Derrida say is say that. I was taught Heidegger, and the whole of my life has been an overcoming of Heidegger. And its influences, so was mine. I wrote a book called Forget Heidegger at one point. So I put my cards on the table. I'm skeptical of Heidegger. But I'm just wondering why that sort of process-based philosophy, Alfred North Whitehead, and those kind of people were not engaged with. And it was Heidegger that was the access to philosophy, as it were.
Yeah, lots of good questions there. I think more than at the moment, Deleuze and also Simondon and Whitehead and so on are actually becoming much more prominent in these debates. I think it's like there is a sense in which maybe phenomenology has given us what it could give, and people are hungry for other fresh concepts to apply to cognitive science. And like I said, at some point, it has been kind of hard to do science with phenomenology. So it's given us clarity about the complexity of our experience in one way, but it has left the interaction with that experience and the rest of the world kind of like unquestioned or, not illuminated and sometimes maybe even even denied, so in some versions of phenomenology there, science is just one practice of the life world and, but doesn't really manage to escape, from our sphere of consciousness. So I think that's been difficult. But in terms of the psychoanalysis and so on, I do find that some people like the things that I'm doing because of the black box approach. So let me just bring that back just for a moment. I'm talking about this slide here, right? So in a way, most of cognitive science adopts a kind of direct isomorphism between mind and brain. Okay, these are the neural correlates of consciousness, for example, that if I have a certain kind of mental state, it supervenes in a particular brain state, and these are tightly coupled. They always have to coexist in a way. Identity theory pushes this even more. They are just one and the same in a way. What I'm doing here is adding some uncertainty in the relationship, which to some extent, then the question is, well, how do we get access to this? And then something like, depth psychology will says, well, maybe dreams are kind of informative after all about aspects that we normally don't have direct conscious access to, could find a new home potentially. I haven't, thought about it in that direction too deeply. But in a sense that the kind of metaphysics of presence, which were very much dominant in body cognitive science, are becoming a little bit more nuanced. And there's now also acceptance that there might be phenomena which we cannot directly experience or measure. And both phenomenologists and natural scientists don't like that. They both disagree for different reasons. So the natural scientists don't like it that they're unobservables or unmeasurables. That sounds unscientific somehow. But for the phenomenologists to accept that there are phenomena which cannot be, that there is a part of reality which is not phenomenal is also hard to swallow. But actually, maybe both of these need this kind of opaqueness in a way in order to be connected. That's exactly where they are connecting. So the world shows up to consciousness. If it shows up as world, well, it's not consciousness, so it can't show up as such as world. Same with the natural sciences. So if consciousness makes a difference, we can't measure consciousness directly. It will show up as a breakdown of what normally can be measured, in the sense that there's an increase in uncertainty. So, but other than that, I don't know why. There must be some historical reasons why Varela, for example, was more attracted to phenomenology. It was more Merleau-Ponty for him than Heidegger, I think. And Merleau-Ponty always was more open to the sciences. But I think what's useful there is that this kind of reflection of bringing us back to the concrete. That's what he liked about it. So to say that before we engage in scientific debate, let's just remember again that we're actually human, and this is we're in the world, and we have bodies and these kind of things. So that's I think where some of the attraction of Heidegger comes from.
Yeah. No, just to maybe I'll just quickly follow up and say, well, I think that I know Andy Clark quite well, and he basically sees his work on natural-born cyborgs as a kind of emerging out of the Merleau-Pontian tradition and trying to take it a bit further, going beyond the body schema to think about the extended mind and so on. There's a clear trajectory there. I would just wanted to think in terms of the black box. I mean, what makes neuroscience so kind of vital, so important these days, has been the relationship with AI. The fact that obviously AI is based on neural networks. It's kind of in some sense learning from the brain in some way, but also maybe vice versa. And I'm struck by the fact that, of course, Anil Seth did his PhD in AI before going into neuroscience. And two of the British Nobel Prize winners in AI, Geoffrey Hinton and Denis Hassabis, have a background in neuroscience. In fact, Denis Hassabis did a PhD in neuroscience, and that's kind of interface that you cannot have AI without neuroscience. It's kind of becomes vital to all that. Has become central, I think, and that's what makes neuroscience really important today. And I guess the question, of course, is and what I constantly come across. I'm writing about neuroscience, about AI right now, and refer to Anil Seth and a few others. But what I constantly come across is the degree to which AI becomes a mirror in which we can kind of sense how the human brain operates. Now, there's nothing in any way scientific about that, because traditionally these have both been black boxes. The brain is a black box, the neural network is a black box. But what's happening now, and I've just been listening to the discourse going on in AI at the moment, is that they're beginning to understand that actually maybe the neural networks are not the black box that we thought they were, and they're beginning to unpack them in some sort of way. So that maybe opens up the possibility that maybe the mind also is perhaps not as much of a black box as we thought it was. And so I would just float it out that maybe we're in this sort of moment where possibly that black box, those theories maybe could be starting to be challenged in some way.
This is a hugely important topic, and I think that we're going to learn a lot moving forward. So one thing that I don't think is emphasized enough is how much embodied cognition and the enactive approach is struggling in a way to make sense of the current AI revolution. It's totally unexpected. I mean, coming from, let's say, Heideggerian critiques of technology, going through Dreyfus, who says, AI will never do anything human-like, especially not language-related. And then suddenly, a few years ago, boom, we have large language models and they're transforming industries across the world. We use them daily now in our lab to do, all kinds of scientific support for us, programming, whatever, asking questions. So why didn't we see it coming? What was it? And, I've written papers on this saying, oh, they don't have biological bodies, therefore they can't do sense making, therefore they can never do, human level competences. And now these things are here and they don't have biological bodies. And yes, they are working a little bit like human brains, but maybe also not quite exactly the same because, they're just mathematical. They don't have all the messiness that Varela was talking about. And so what's going on there? But one thing that interestingly comes out of this framework, and it was not planned, but is that the indirection here actually opens up some opportunities for rethinking about our own language production, in the sense that what we do with our mouth is on the side of the world. It's part of the natural sciences. There's stuff moving in our face. It's matter moving around. So whatever we're doing, it has to be somehow on the side of nature. And in a sense, what these large language models maybe suggest is that most of what we do with language is unconscious. Okay, so then Heidegger has a nice concept for this. Das Man, one does. There's a kind of conventionality. It's a kind of public social structure into which we can reach into and make use of, but then we act inauthentically in a way. But in a sense, what these systems do is model that. They're modeling the public, conventionality of our social interactions and showing us that you don't need to be an authentic conscious agent in order to behave through those kinds of operations. Anyway, that's just, my very speculative interpretation at the moment. But it's something that, was not expected from the side of embodied cognition. People thought that consciousness and human level sense making would be necessary for human level linguistic competences. And now it seems like they're not. So something has to change there. It seems like there's a lot more intelligence happening at the unconscious level than we expected.
Can I just briefly, so I don't want to hog this conversation, but just briefly, just follow up on this embodied consciousness thing in some way. I mean, I think the critique I've always had of Heidegger and other people as well have had, especially on his discourse of tools. The tool is either ready to hand, I forget what the terminology he uses, but they're kind of black and white. But what, of course, Merleau-Ponty talks about is how they get absorbed into the body schema. We absorb them. The person with a stick, blind person with a stick is thinking through the stick and so on, which was kind of the basis in some way of what Andy Clark was talking about in the extended mind and so on. In some ways. So, you have this capacity to absorb things and I worked on this idea exactly parallel to Andy Clark. I produced a book based on psychoanalysis and critical theory, looking at adaptation. He was looking at neuroscience and looking at kind of adaptation. But the same logic was actually behind both of them, which is kind of interesting in some ways. But my point would be this: is now we're in a situation where, when we talk about AI, more about extended intelligence and about the way we engage with AI. To become an extension of the self, and especially when we get these personal AIs that are appearing, and the way that people are interacting with ChatGPT and all these things, so it becomes almost a tool by which to think, and that is really, positing. I mean, it goes very much in line with Andy Clark's thinking, but really positing there's something that is not embodied, that is becoming part of the equation in how we're existing in an AI-dominated landscape today.
Yeah, definitely. It's changing how we think. I think it's empowering. If you use it in the right way, it can empower how we think for sure, and it can nicely support interdisciplinary research. So in the sense that before I talk with professors down the corridor about their latest research, I can get like a quick, hint at, am I actually thinking about this the right way? In a way that's would be otherwise impossible because it's interactive and so on, right? So I think that, that kind of first step, you cannot become an expert through their use, but you can basically become generally quite well informed to at least ask the right questions. That's already a big help. Yeah, much more to talk about there for sure.
Thomas, do you want to go ahead?
Yeah, yes, thank you. You hear me?
Yes.
You hear me, Tom?
Yes.
Yes, I would like to go back 28 years at the time when I was in Berlin, University of the Arts, and I was in contact with a neurobiologist, Karl-Heinz Menzen of the Sigmund Freud University in Vienna, and as an architect and engineer, interesting in the ever-evolving response to the changes in tools, protocols, and methodologies. He recommended to me the tree of knowledge from Maturana and Varela, the water drop, the mountain with the water drop, how this analogy has an influence of living systems that adapt to the environment through their lifetime, through their lineage, including ontology. And this environment always independently or dependently is reproductive. And in those stages, and it influences their growth, how to adapt to the environment. Now, you have not showed or discussed the water drop model, and I think it's still existing, even with the improvements in tools by using today large language models that help us to explain the world and present connections to the brain. But it's always in motion. And at that time, 20 years ago, you might remember there was this phase of the intelligent buildings with Wilhelm Flusser, who had a huge influence, in particular in Germany, to talk about intelligent buildings. And Flusser was actually focusing on the squid or the octopus who decided in evolution and not to adapt to the Cartesian geometry. The opposite, to look at the unlimited liquid space and adapt with so many mini brains and tentacles. That also represents today the opposite of the hardware and increasing science to include more wetware with mini brains that can now communicate with each other, from a lab in Berlin with a lab in Rio de Janeiro. How do you see these things in context with your presentation?
Wow, well, there's quite a lot here. So, I mean, the Tree of Knowledge is great. One of my favorite books. I think a lot of what I'm doing here is remotivating that to some extent, but adding a little bit of nuance in the sense that the kind of mechanisms that you describe, we can think of them as a way of cultivating our habits in a way. You know, like now applying them a little bit more at a shorter time scale than evolutionary thinking. But and you know, if what I'm saying is on the right track, it means that we can't directly control our behaviors. It's not possible because we don't have access to from our mind to our body, and also our body is messy and it has its own tendencies and autonomy and so on. So we can't do direct control like the engineers would like to have us, you know, like you could do with a robot, for example. But what that means is that two possibilities. Either it means that we're not free at all. Okay, that's some kind of like neuroreductionist nightmare. But we don't have to go for that. Another possibility is that we only make a very minimal indirect difference. This is what I'm trying to conceptualize here as Irruption, which is basically from the point of view of our brain or our body, the mind is a perturbation. It's something that you can't make sense of. It comes from somewhere else. It's not the physics of the neurons doing it. There's suddenly a variation that can't be made intelligible in terms of purely physiological causes. So from the point of view of the system, this is an external perturbation. It's a noise factor in a way. But actually, it turns out that this noise factor is exactly what the system needs in order not to get trapped in local optima. It gives it extra degrees of freedom, extra variability, a kind of resource that it can then use in order to jump between trajectories, for example, or to break out of a rut, for example. And so the combination of these two, and the ability to basically inject noise in the system in such a way that you can break free, and at the same time being a body and in an environment in which the natural tendency is towards convergence, the two together basically give us our metastable complex adaptive behavior. And so we're free, but not free entirely. We're just kind of free to give our body new opportunities. It's like our agency is opening up degrees of freedom, but it's our bodies and our tendencies and trajectories and our environments which close off those degrees and let behaviors crystallize out depending on the conditions. And then, that repeats and that was cycles. So, but in the very beginning, we don't have it. So if you look at a newborn baby, it looks like full of intention, it wants to grab, it wants to walk, it wants to engage, but, the limbs just don't connect yet. They just move around. It's called motor babbling or intention babbling. And it takes time for the body to learn, so to speak, when I get this noise happening, what is it that I should be doing in order to kind of like, make the noise go away? And then you learn, develop over time. That's so in a way, it is indeed this kind of spontaneous self-organizing flow. And the only thing that I'm adding here is this extra term where your effort as an agent is something that can toggle the degrees of freedom that the system is at any point in time. And the higher the degree of freedom, the more easily you can jump between trajectories.
Thank you.
Yeah, sorry, and one more part with the technology. Sorry, this is also important. So yeah, we have to be careful with the technologies. On the one hand, they can be a very convergent force. So they can amplify, convergence. So if I always use Spotify for my playlist, then maybe, I will, always be, it will suggest songs to me based on what I've listened to in the past that are similar somehow, and therefore it's less likely, for example, that I will listen to something completely new or something along those lines. So, or we get some kind of like positive response from chatting with ChatGPT that always tells us, yeah, you're great, your ideas are the best, and so on, without giving you any critical feedback, telling you maybe you should be thinking about this differently. So we have to be a little bit careful that a lot of these technologies are somehow, the profit comes from engaging you and keeping you in the same loop and not allowing you to jump out and doing something else, right? So screen time is money in a way. Attention is what's getting the profit. So we have to be careful. But on the other hand, if we use these technologies effectively, we can use them to do the opposite for us. So one trick that I like, for example, for ChatGPT is that you can ask it to be an adversary for you. Let's say you want to submit a grant proposal or a paper, then you tell it, I want you to be a reviewer or the editor and go through this with a critical mind, looking for things that would make you reject it. What would those be? And then you upload the document, and that's a very different interaction, and it can do that quite well. So basically, then you're using this technology to diversify rather than to kind of amplify your own predispositions. But yeah, it takes some care and careful managing how these technologies channel our flows of activity.
Tom, one more question, I'm sorry. What about interorganismal communication? We are more and more capable to communicate with root systems of trees, with dolphins and other species in this environment of adaptation and conservation. The more we are able to decipher these signals and communication streams, the more it will change our behavior and the tools, the workflows and methods. It's going to be radical. How do you see that?
Two things. So on the one hand, I'm completely on board with that. We're part of a larger system. Okay, it's a huge, complex system with many scales of organization and lots of different levels of agency too. So we can talk about the agency, for example, inside of our body of each individual cell. How do they relate to the larger organism? As I mentioned, for a neuron in your brain, you as an organism is not conceivable, right? So if the neuron has to do something because we as a whole organism want it, for it, it's basically, some strange imposition from beyond, right? And then it goes out us too. So our social systems also can, operate with respect to goals, and maybe even ecosystems. So we're looking at that a little bit. So according to eruption theory, for example, regulation, adaptation, so effort to make a difference would show up as increased stochastic fluctuations. That's the concept of eruption. Okay, and now what's the signature for climate change? Well, it's increased stochastic fluctuations. What does that mean? Of course, the causes could be different, but just it's interesting to just entertain the thought for a moment that if we were to look for a signature of agency at the planetary level, it should show up as stochastic fluctuations. And so, I don't know, it's early days, but I think we should have an open mind for that agency might show up at different scales. Whether we can understand it like in an intelligible way, I think that's going to be much more challenging. I think, even within our own body, there will always be this kind of black box standing in the way, that in the sense that we get the signals that something is making a difference, but we will not really be able to understand why or how. So we might just have to trust. This is an issue about trust, in the sense that once there's an indirection, there's no longer complete transparency across the levels. It's a source of our freedom in one way, but at the same time, what it requires to work properly is trust that the other levels, which you can't control and which you can't understand, are doing their job properly. And once that trust goes away, things go very bad very quickly. So if you constantly self-doubt, for example, something that schizophrenics, for example, do, it's called hyperreflexivity. Eventually, your whole body starts disintegrating, and you lose, like, body memory and things, everything. So, you have to basically let go and let the process flow. And even if you don't understand why it works, and yeah, so you have to cultivate a certain kind of empathy that kind of substitutes for direct communication in a way.
Thank you.
Yeah.
Martin, do you want to go ahead?
Yeah, I would like to see if we could reorient this back to architecture in some way. But maybe in the interim, I could just mention that that there are two things that I would think you might want to re-emphasize in Varela's project, and that is the multiplicity of cognition and cognitive multiplicity as laid out in what I think is really one of his most important works, which is the specious present, which has its roots in Husserl, to connect to the earlier conversation about Heidegger or Husserl or Merleau-Ponty or so forth. And I've been applying it to understanding the complex adaptive system of a jazz ensemble, both in terms of embodied cognition and distributed cognition. But some of my insights came from work that I had been doing in the early aughts on the avant-garde architects Arco and Ginz. And I don't know if you're aware of their work, but they came up with a notion of landing sites.
Okay, sounds interesting. Yeah.
And what it turns out that as what they call an architectural body propagating through an architectural surround, and very monist in their orientation, that we process the world simultaneously in different ways. There are perceptual landing sites, there are imaging landing sites, and there are dimensionalizing landing sites. And these correspond actually precisely to the 1-10, 1 and 10 scale laid out in Varela's specious present. And what made me interested about this is that this also applies to the difference between the way jazz musicians practice at very slow cognitive speeds, but when they're interacting with the other jazz musicians, it's occurring beneath the threshold of conscious awareness, and yet they have to try to juggle fast and slow cognition. Otherwise, the universal experience of jazz musicians is that everybody gets lost. And they get lost when these two different forms of time cognition interfere with each other, almost in a cybernetic model of creating noise. And that seems to be what's going on with what Arco and Ginz were getting at when one is, for example, moving through a surround and interact with that surround at different speeds. But I often tell a story about one time when I was walking to my student union at during an alumni event, and I had been on campus for 5 or 6 years, and they had built a portal around the front door to the student union, and I was so busy engrossed in a conversation with my friends that I was relying on previous maps, which correspond to imaging landing sites, that I was no longer paying attention to the perceptual landing sites, which are the immediate data. And as a result, I ran into the glass portal and broke my nose. So the tension between those two forms of time cognition, where there's actually noise going on, suggests real palpable ways of understanding what Varela is getting at. And then there's the other issue of neuroplasticity. And so I'm wondering, how you might connect Varela to architecture.
Wow, yeah, very, very interesting. Thank you. I really like this concept of landing sites. I will look it up, or if you could send me something, I will take a closer look. It fits very well with what I was saying before, that what I call eruptions, the messy, the breakdowns. They don't occur into nothing. There's already a context of ongoing activity,
Right.
which will shape how they will unfold. And it's the interaction between the two
Yeah.
that determines what kind of behavior will come out.
I also think, if I could just interrupt just for 1 second, that the three categories that Varela talks about, he often refers to as, bifurcations in phase space. Isn't that the language that he uses? With one dimension, with respect to the complexities involved. And this really fits into jazz. And I track, cognitive bifurcation at the level of melody, harmony, harmonic rhythm, and percussive rhythm as they are interacting at very fast speeds, while also trying to keep in mind the template of the song narrative represented by the lead sheet of a particular tune, and then there's the issue of neuroplasticity, where these contingent stochastic moments of adaptation, if become regular, then can be hardwired in a neuroplastic sense. And a lot of people writing about music and the brain really talk about evidence of neuroplasticity. And so I was wondering whether that connects to your notion of eruptions.
Yeah, no, plasticity is crucial. This is what allows eruptions to shape behavior in the long run. So we can't do any cultivation or habit changing without plasticity. So it's absolutely essential that the system is able to adapt and to change over time. And I've always loved those timescales that you mentioned. So the species present, I keep returning to it and asking new students in the lab to read it and so on, because I think it's one of the most fascinating things that Varela wrote.
I found it very fruitful to apply this to specific. I'm kind of coming out of a Deleuzian perspective, and the way he talks about the importance, he exhorts us really to establish, to forge alliances among scientific functions and percepts and philosophical concepts and artistic constructs. And so when I work, I tend to put the three together with specific circumstances. And it just turns out that jazz and architecture are two places where this happens for me. I also did literature, but that's—
Sorry, Martin, let me just turn on the light here. Energy saving measures. It just went 10 p.m. over here in Okinawa.
Yeah. Anyway, so I'll stop there. I didn't mean to take up so much time, but I'm just, I'm thinking about the actual application to architecture.
Yeah. So about the time scale, just a couple of brief comments. So One is that the approach that Varela outlines in the thesis present is still based on dynamical systems theory. He talks about recursion and things like that. But dynamical systems theory, at least in the deterministic form, is fully reversible. And so then one aspect of time that he leaves out from his account is the direction of time. Like, where does it flow into the future or does it flow into the past? So he has the concept that allows him to talk about windows of integration in a way, but he doesn't talk about, which way should it be going. And one hope I have is that in future work, eruption theory could add this direction aspect, because to an extent, if eruption happens, it would make whatever process is occurring irreversible. So you can't just run the physics of the deterministical systems backwards anymore, because now there's a noise term that basically is messing things up for you. You can't work out what it is that got you from A to B anymore. So that's interesting, because it introduces irreversibility into his account, which is absolutely crucial for any account of time, but which was absent in his original proposal.
And my God, to begin with, at the very early stages of my graduate work, was Ilya Prigogine. And so, and his connection to Bergson, who was someone that was not mentioned earlier with respect to Heidegger and Husserl and Merleau-Ponty and Whitehead, although Bergson influenced all of those. If you think about his original project, which was basically in order to talk about intuition and creativity, talked about the impact of clock time and calculus from the Industrial Revolution onto human cognition. I mean, what he's really talking about is neuroplasticity, isn't he? And so I think, given the enactive revolution, which is something that I very much have bought into, I think it's worth reevaluating Bergson's role in all of this, because he influenced Husserl. Heidegger's relationship is a little bit too weird to get into right now, but Merleau-Ponty, Whitehead, I mean, they all talked about him. And I think we need to revisit that early work of his with respect to cognitive multiplicity, with respect to neuroplasticity, with respect to enaction in terms of how does the environment impinge on the mind, as well as the mind act in the environment, and so forth and so on.
Yeah, thank you. So I think it would be nice to actually talk a little bit about architecture. So maybe also some other of our participants might want to join in and let me know what your thoughts are about the relationship between enaction and architecture. But one thing I can maybe generally refer to is that we have one application of the framework I presented today is what we call way shaping. This is something that's happening with other members of the unit, where the idea is in a way that once we are accepting that we are not directly in control of our behaviors, but in the sense that we have to plant the seeds and cultivate the kind of flows out of which our behavior emerge, then of course being in the right kind of environment plays a huge role for that. And so the way in which we design our external environments now becomes crucial. So, I mean, we can go back to Andy Clark, we talked about before, in terms of extended memory and so on. Like, I leave the keys by the door so I don't forget them. That's just a very kind of banal example. But going more deeper in that direction and really thinking about what can we do with our environment such that it, for example, facilitates certain plasticity, or maybe allows us to converge more in one direction, or maybe it invites us to, open up in certain ways. I think that's really nice in the sense that, classical cognitive science, if you buy it, then, the mind is a computer run by the brain, and the environment doesn't really matter to some extent. It's just it's a source of inputs to a predefined architecture. I mean, architecture now in terms of organization of the brain, but it doesn't really change or constitute fundamentally what the brain is doing. It's just providing it with inputs. Once you move into a paradigm where behavior and cognition in mind is actually a relationship between brain, body, and environment, it's something that emerges out of the complexity out of those interactions. Well, then suddenly the environment becomes a key player in this. And given that we humans actually have the capacity to design our environments, a theory of the mind that says that the environment actually partially constitutes our mind, well, actually, you know, then architecture becomes hugely important for thinking about mental health, mental capacities. How do we experience things? How do we experience each other? You know, architecture is not something that is outside of the mind. It's actually, to some extent, designing part of our minds. You know, thinking through that a little bit in detail, I would love to, you know, do that a little bit more. I don't have a lot of experience exactly about, you know, what architects are up to these days. But, you know, I think there's a huge opportunity to take advantage of the things that are happening in cognitive science to think that, you know, maybe we should highlight this much more explicitly, that we can't take, you know, our environment outside of our minds. And hence we should design them very carefully.
Thank you, Tom. I think these last couple of words that were super interesting, and I'm sure we can come back to this. I'm going to take like a little bit of liberties here and also insert a question. Actually, I would have so many questions, but let me think of one, which maybe not totally unrelated in a way to what you just said. I did watch your conversation with Mike Levin when it came out on eruption theory. I'm sure you've addressed this, what I'm going to say in one way or another, but let me just quickly come back to it. And this question of interaction, and something that Mike says here, I'd love to hear how this relates to your framework. When he says that one currently unpopular view in philosophy of mind and cognitive science is that of interaction as dualism. The proposal that the mind is a radically different thing than physical objects and forces, but that it interacts with the physical brain and body to make a functional causal difference in behavior. I will comment on mind-brain issues more in the forthcoming work. That's his work. But meanwhile, I wanted to provide some resources for a specific aspect of this set of ideas. The argument that interaction is impossible because it would violate energy conservation. In other words, if physics describes all of the interactions between particles in the brain, how can an immaterial mind make a difference to what happens in the biochemistry of the brain without running afoul of the energy accounting at the microscale? I mentioned this now because set of fascinating papers by Tom Froese, Irruption theory. So this notion of interactionism, which I take when you say that, to the best of my understanding, mind and matter are intrinsically coupled and yet fundamentally irreducible. Maybe you can elaborate a little bit on this notion of interactionism from your perspective and how it may fit into, or maybe also be in certain tension with what Mike just laid out here.
Sure. Yeah. Thank you. This is very difficult topics, so I'll do my best to try to you know, clarify them. So interactionism, I think the way at least I understand it from work by Popper and so on is not exactly what I have in mind, in the sense that they actually start from, you know, accepting dualism in a way. Actually, it's like a triadic. So we talked about this a little bit in our conversation previously. So they, you know, they have the objects of nature, then they have mind, and then they have mind-created objects, right? And so and architecture, I guess, falls into the third category. So it's, you know, it's interesting to maybe unpack that further at some point. But they really make ontological, very strict boundaries between them, and then the interactions that are happening are conceived as if they were kind of interactions within each domain. So, you know, like the mind makes a difference on the physical side as if it was a physical object. For example, changing something in terms of how the brain works, you know, like, you know, I imagine they would say, you know, maybe it can make these neurons fire in a different way, or I don't know exactly what that would look like, but it's like almost like an invisible hand, you know, shaping things in a way that fits, that aligns with whatever intention is supposed to be acted out. And so I'm very careful not to try to say something like that. This is why I always say we're not in control of our behavior. So the relationship I posit here is not of that kind. It's not that we somehow can like ghosts, like, you know, reach into the world and then move things around according to our will. So the only thing that we can do is disrupt things in a way. So this is where the uncertainty aspect comes in. It's a disruption. So that disruption would not exist were it not for effort made on behalf of the mind. So in the sense that, yeah, there's something different here, but it's not an interaction in the sense that one billiard ball is hitting another billiard ball or something along that, very clean way of interaction. And then still there's the question of, how could this be useful? I think I answered that already quite a lot now in terms of, it depends on the flows and the context and the landing site. I like that concept, and opening degrees of freedom and so on. But what about the energetic argument? And are we violating physics here or not? And this is a tough one. My current preference is to actually argue for a kind of broadened naturalism. So let me just bring that slide back. That's kind of helpful to see it again. So on the side, I have nature and reality, and they're actually the larger circle. So I do see this framework as a naturalistic framework of a certain kind. I don't want to see this as a metaphysical dualism where of a traditional Western philosophy. So it is a naturalism of a kind, but it's a broadened one in the sense that what I posit is that there are aspects of nature which do not fall within the domain of observable matter. But that in itself is not so outrageous in the sense that possibly even within physics, there might already be phenomena that are not directly measurable or not directly observable. Think of dark matter or dark energy. They're not perfect analogies, but basically we notice that something is making a difference, but we don't quite know why. But we can measure the effect of it. Or if you go down to the quantum level rather than up into the larger scales. So if you go to the smaller scales, there are also surprises waiting for us that in a way indeterminism lurks, and we don't know why the Bohr's rule applies the way it does. So why is there the uncertainty principle of Heisenberg? Who knows? But basically there are limitations to what we can know. So that's kind of more the framework that I'm positing here, that in a sense, there are natural phenomena, which we might call mental, which make a difference, but which are not amenable to the usual ways of carving out nature. And so one way of deriving eruption theory is by applying some kind of dimensional analysis. So if you think about the standard units of physics, so let's say voltage, mass, or also all kinds of metrics, basically. What Descartes already noticed, and I think he's right about this, is that this doesn't apply to consciousness. It doesn't apply to our mental properties. So if I say I have an intention, it doesn't make sense to say, well, how many volts is your intention? It just doesn't, you can't put that kind of phenomenon into terms that we can measure with standard metrics. But that means that when we come to thinking about how could it make a difference in systems that do have metrics of this kind, then we're limited in a way to picking out those quantities which do not have physical units, because otherwise we would have to find those matching physical units on the other side of which is making the difference, the cause. In order to have equivalent units on both sides of whatever relationship we want to establish. But fortunately, there are those quantities. So for example, relative phase, which is one of Varela's favorite ways of measuring synchrony in the brain, is a unitless quantity. It's a ratio. And actually, it's also a kind of scale invariant ratio. It doesn't matter when the angle is the same, no matter whether, it's this long or the vectors are super long, right? So it doesn't matter the scale of the vectors. It's just the relative angle between them that tells you whether they're in synchrony or not. And so that's very fascinating to me, that already the kind of, or information, it's another information theoretic notions are also these kinds of ones. So the kinds of quantities that neuroscience has already picked up as particularly useful for trying to define what are the neural correlates of consciousness, for example, are dimensionless units. And that makes a lot of sense if what we're trying to relate here is a natural phenomenon, but one that can't be described in the usual units. So there's probably, some difference there between me and Mike Levin that would be worth unpacking a little bit more. He doesn't seem to see a problem with energetics, and I can kind of see why. But what the more important difference between what we're saying is that what's the possible range of influence, right? What can actually be controlled over this interface? Interactionism seems to allow a much more control or shaping than eruption theory would allow.
Very interesting.
This is
Yeah.
this is not,
No.
I'm talking out of the top of my head here. So this would have to be, worked out carefully in a new article, I guess. But this is kind of like, some work in progress at the moment where I'm trying to articulate better what actually the kind of metaphysical commitments of this theory actually are. But my current feeling is that the best way of thinking about this is that it's another aspect of a broadened naturalism view of reality, which is just not measurable. That's all that we need to say, really, that, we do have access to it first personally. We know that we do things for a reason, that we have experiences. But when we apply scientific instrumentation, it's something that doesn't show up, but also for good reason, because basically the units that we can measure are not ones that apply to the phenomena that are mental. So in that sense, it's kind of a consistent picture.
Yeah, thanks, Tom. That's for me. I'm certainly entirely stepping out of my competencies here, but I find it incredibly fascinating. And ultimately, the project would be to relate all of that from my perspective back to creative practices, which I think we're touching upon as well. Tom, are you doing okay time wise? Do we have some time for a few more, one or two more questions?
I thought it would be nice to answer maybe the people who posted something in the chat.
Yeah, exactly. Exactly. I okay. Maybe if we can, I'll read Waskar's question, and then there's a fantastic question here by Sonia. I'm sure she can read it herself. But that's Waskar. I'll read your question. Is that good?
Please, can you read it? Lots of sound around me.
Yeah. Okay. This also brings us to a somewhat different context now. So Varela was influenced by Buddhist philosophy, particularly in his exploration of non-dual awareness and mindfulness. Do you think his work offers a viable framework for integrating non-Western epistemologies into contemporary cognitive science and philosophy of mind?
Yeah, it's very much Buddhist philosophy is very much in the background still, also for eruption theory. Of course, it made a huge difference for Varela's work, philosophically speaking, methodologically speaking, and I think even the way I would think about eruption theory is taking that particular aspect of his work more seriously than maybe even he did in some of his writings. In the sense that this non-duality that you pick up on your comment, that's exactly the core of why I posit eruption theory as this kind of complex, intrinsically linked, but not directly interacting and so on. Maybe the source of the inspiration is a little bit different from Varela. So he's very much coming from Tibetan Buddhism. I think for eruption theory, the kind of Buddhist philosophy that I found more helpful comes from a Chinese Buddhism, early Chinese Buddhism, which then later becomes Zen Buddhism in Japan, because they have a very helpful way of talking about a kind of threefold conception of reality. So this goes back to this conversation we just had about is this dualism or not? If I had to put down a kind of ontology, maybe I would put a threefold ontology. So you have kind of conventional reality on one side, which is made that which is accessible to the natural sciences. You have a kind of Buddha nature or consciousness side to reality, which is accessible to us from the first person point of view. But those are not the only two, because if we were to stay at that level, they would always basically eradicate. So either you're on one side or on the other. This is what we also had at the beginning of my talk, that you fall into these kind of extreme ends. So what the Chinese system posited as a solution to this paradox is the reality of the middle. And the middle is not, just another thing. No, it is somehow the middle of the two, but without being either of them. So if one reaches into the other, if you want, it becomes something novel. And that's kind of like maybe referring back to Michael's point. This is the creative process, right? So from the point of view of consciousness, if the world reaches into it, it's something that is unintelligible, creative, inchoate, is some sort of like, stimulation, perturbation. But also vice versa. If the mind makes a difference to the world, again, it's something that from the point of view of the world doesn't make sense. It's unexpected, increases uncertainty. But in a sense, it's the insistence on the reality of the middle, which basically gives life to this entire framework. It's what allowed me to conceptualize eruption and absorption as meaningful concepts, and then start a research program to actually try to measure them and say, hey, we've got all this work already in cognitive neuroscience, for example, that tracks neural entropy using information theoretic terms while people engage in cognitive tasks, and say, well, they do it because it's useful, but now we can actually give a kind of conceptual first principle response to why should we expect that complexity and uncertainty goes up when people make a cognitive effort. So there's still probably a lot more to be explored there. I haven't. It's just so much going on. But yeah, I mean, I find that this triadic framework is super helpful, and it's something that is very much missing in contemporary debates, where if you're not on the side of a monism, either it's some kind of radical constructivism where it's all just the social, or all just the mind, or all just consciousness, or on the other side, all just physics, or all just nature. Like if you're not one of those, people don't understand what you're saying. You're like, what? How can it be different? You have to choose sides. Like if you're not on this side, you must be on the other side. But I don't find that helpful at all. I think we should just hold off on that decision and just allow for a moment the tension to exist, and recognize that there's a tension there, and then that tension itself might just be part of what reality is about. Maybe we can never get rid of that tension. It's just what it is, and that's okay. We can work with that, and we can even measure it. And we just have to get used to it. and so mindfulness practice and all these meditation techniques, and so actually what they help us to do is to get used to that. We live with the uncertainty, and we make use of it in our lives as a resource.
Thank you, Tom.
You're welcome.
Sonia, would you like to ask your question?
Works. Let me see. I don't think my video is working right now, or use video.
We can hear you in any case.
I don't know what happened. I think it might suddenly start. That's what happened last time. But anyway, I'll just go with voice, spectral voice only. Thank you so much, Tom, and thank you, of course, Michael and Neil, for organizing these amazing meetings. So my question is kind of a word salad. I have this tendency, so I will read it out loud. But basically, it's coming from the context of dealing with this friction or staying with this uncertainty that you just spoke about. I was writing about the entropic brain a while ago, and reading a lot of Nishida also. And a friend pointed me to your work on Irruption, so I also wrote a little bit about it. It's not published yet, but I'm still working on it. And the question is basically about this kind of eternal fight with language or with modeling, or kind of carving nature at the joints. So I'm gonna read it out loud.
Sure.
So in the context of active inference, right, we have the trade-off between a kind of predictive reward, finding what we expected to find, and then learning from novelty. And then eruptions would be an example of the latter, right, where you have the learning from complexity. And in the context of language, I'm thinking, so error minimization is kind of everything right there. We use concepts so that we actually sort of can, create networks of what we call shared meaning, where shared is always like the open question, like how shared is it? But what makes up language in its entirety could be a sort of this mega structure of prediction error minimization for social beings that can use symbols, etc. So I kind of see it as a sort of, could be a hyperprior that is just expressive of error minimization across the board in all organic tendencies we see. But it could be also a strange effect of language itself, leading us to this kind of permanent fight with it, right? In this sort of modeling frustration, capturing reality of frustration, etc. So the question would be, do you think that it is possible to sort of modulate our linguistic frameworks to be more attuned to 5E considerations, to be more attuned to kind of metacognitive, meta-perspectival understanding of how complexity is generative, how eruptions work at these higher scale levels, perhaps connecting us all. And I'm thinking that a system like philosophy is something which already does this in concept expansion and concept sort of deconstruction and re-examination and creation. But maybe there are other things that you can think of. You spoke about language earlier, and I was immediately, sort of inspired by this as well. So thank you.
Yeah, thank you. Let me just say, I think something about predictive processing first, maybe, and the free energy principle. So this is something that I'd love to, work out in more formal terms at some point, because they have the advantage that they have a very sophisticated mathematical framework, which eruption theory lacks at the moment. So if there's something that we can make use of there, that would be great. The way I think of it at the moment, though, is that to some extent, they are describing a smaller part of what the eruption theory story is about, which is the part about the convergence aspect. So we talked about that before, right? So, the rivers, converge, they flow down, they carve the landscape, and they're more likely, again, to stay in those ravines the deeper they go, and so on. It describes that kind of process very well. But, my feeling is that that's not what's going on with living organisms. And of course, they also recognize that, which is why they say, well, evolution gave us priors to also sometimes search for surprise and so on. But it feels a little bit artificial to, give evolution that role. I feel it's probably fair to say that, we need an additional principle here. It's not always just about, surprise minimization or, prediction error minimization. Yeah. So this is what eruption theory gives us, basically. It gives us from first principles, a reason to think of why should there ever be an increase in uncertainty in the system? And we can kind of derive it from this disconnect, in terms of physical units or, ontology, depending on your preferences, that, what the mind does to the body from the point of view of body just doesn't make any sense. It's like an additional hidden variable that's just injecting noise into the physiology in a way. And that's nice, because then we can say, well, this is what pumps up the variability. And then we've got like the predictive processing framework to kind of narrow down that variability again and remove that surprise and, use that to generate action, for example. So this is one of the things that I think where it, ties in beautifully, where if we think of active inference, action generation as basically a way in which the body removes prediction error, well, eruptions to some extent are like the ultimate prediction error. It's nothing that the system could ever do to predict that an eruption is going to affect it, because it comes from something other than its own physiology. So what is it going to do? Well, if it makes the right action, you're going to stop making the effort. And so the eruption goes away. So it's exactly that process, which, fits very nicely there. Now about the language. Yeah, it's interesting. So one thing that comes to mind, because Derrida was mentioned in the beginning, one thing that I really appreciated from his work when I was a student was the concept of difference.
Yeah.
Like everything is already somehow self-differing. Even before you can grasp it, there's already some kind of change happening, and it's always outside of our grasp. So maybe every time we use language, the fact that making a difference that's by nature what we do is somehow always making things slippery in a way. It might give a different way of thinking about what we could mean by difference, and maybe eruption theory kind of fits into there. And also Deleuze's The Fold seems to somehow point maybe in a similar direction. So there's some conceptual resources there that we could try to bring to bear to think about our eruption theory. But I think what you have here in mind is, something maybe a bit more general, like how we can use language to make us more aware of this. Could you explain a little bit more what you mean?
Yeah, I'm thinking, so the references you mentioned are strongly figured in what I'm writing about as well. I'm doing this very ambitious and almost even rude, you could say, kind of super broad scope spanning of a lot of different philosophical concepts to put them under the kind of category of the neg-intelligible. So all the things that always prove that there is a friction, always prove that there is an excess, an absence, a fault, a kind of noise.
Yeah, this is super important. So I mean, I'm totally on board with that. I think this is what I also said at some point, that we have to get away from this philosophy of presence. Reality is more complex than that, and we need to acknowledge that and make room for it. So I'm totally on board with that. We have a workshop at the upcoming Artificial Life conference, which is basically about the generative role of noise in all kinds of different scales. So agency, social systems. Actually, just very briefly, some of my work touched on rituals a little bit. So we can think of rituals also again in these two ways. Some rituals are conventions. They kind of like reduce degrees of freedom. They channel things. They channel with. On the other hand, you've got extreme rituals that kind of like disrupt things like rites of passage and I don't know, carnival and things like that, where things get inverted. Maybe liminal spaces, sacred spaces also have that. And so we seem to find the eruption theory, a relationship between mind and body, replicated also at the social level, where the society, to some extent, the way in which it interacts with people, again, is in the same way. So if you go with Durkheim, for example, the way in which the sacred shows up is actually something as the social. It goes beyond the individual, but it's not like transcendent. It's actually just, going to the point of the individual because it's the social. The community is more than me as a self. And so I think there's a lot of interesting work that could be done also in that direction of thinking again with anthropology. Maybe what they were picking up there are similar phenomena at these other kinds of boundaries that we can draw in reality between culture, social, individual, and so on. And eruption theory, in a way, gives us a conceptual framework for thinking about all of these boundaries. Yeah. They all face similar issues, as long as there's a different ontology at play, because it's a different level of agency, for example, similar considerations will apply by necessity. And whether we want to call this really like, an ontology or use a different word here, one way I'd like to talk about it in order not to get people angry about metaphysics is regions of being, for example. The regional ontology seems less harsh. So this comes from Husserl again. But if you think about regional ontologies, the region of that physics applies to, but it can also be the regional ontology of life or of the social and so on. But regional here means that in a sense they're still all part of one reality. So we're not really drawing such strict boundaries, but to the extent that these regions have different specificities, and these specificities make a difference to things happening in other regions, we have to do something like eruption theory. Basically, something will get lost in translation. Yep. And we have to recognize that part. And in order to be properly able to integrate the whole without falling into reductionism.
Yeah, no, absolutely agree. Thank you. Thank you so much. I don't know if you're interested, but I'm pasting in the chat an issue that Cecile Malespina edited a year and a half ago or so, where I have actually an article on the precisely on this, on like how not to lose the noise in the context of this is of natural language
this is very helpful. I will take a look at that. This could also be helpful for the workshop that we're
organizing. She's working a lot on generative noise, and all these people might be interesting for that context.
Okay, great. Thank you so much.
Thank you so much.
Are you using the work of Michel Stern at all?
Stern? I'm not sure I'm familiar with her.
Michel Stern? S-E-R, my pronunciation's terrible. S-E-R-R-E-S. French continental philosopher who just died just a few years ago.
No.
He talked a lot about self-organization through noise. And my dissertation,
that concept in general is we're far from the only ones talking about that part. I think the only real innovation that I can claim there is that that we can find a way of deriving conceptually why agency or mental causation could lead to something like noise. Right. But of course, noise is all over the place, and it's essential for all kinds of adaptive processes.
I think you'd like his work very much. I mean, I think you'd find it congenial.
Great. Yeah. I mean, that's my experience. So my feeling is just that we just like develop a little hinge. That's the only thing we did. But what it does nicely is connect lots and lots and lots of different work, and suddenly you can put it together and say, that makes sense now. But it's basically by giving due role to things that are not exactly intelligible or transparent or present and so on. But just looking at them through the lens of kind of diversity of ontologies, I guess. So if you're a monist with your ontologies, you don't see these things. But once you diversify your perspective, suddenly things fall into place. So that's quite nice. All right, Michael, I think that's it for me here. Thank you so much. It was a great discussion.
Really wonderful talk.
Tomorrow is
Thanks so
Monday
much,
morning
Tom.
here,
Yeah,
so
fantastic.
Tom, thank you so much. It was amazing. Thank you.
Thank you so much, Neil. Thank you so much, Michael, for arranging this very nice opportunity. And thank you everybody for sharing your feedback, and your comments have been noted. And if anyone has anything else to share, I'd love to hear from you. Send me an email. Any references? We're very much still developing these ideas. It's all work in progress. So we're very much open to your suggestions.
Thank you. Thanks, man.
Fascinating. Yeah, amazing. Tom, thanks so much again. Thanks everyone for joining in.
All right. Thank you. Bye.
Thank you.
Bye-bye. Have a good evening, Tom. Bye.
Thanks. Bye.